Hello everyone, and welcome to part 3 of my first robotics programming videos. In this video we're going to start the process of writing a complete program for an FRC robot from start to finish. And we are going to program the code for our team's robot from the 2019 Deep Space competition. If you're not familiar with that year's challenge, I'd highly recommend watching the short kickoff video from FIRST that explains how the game works. So that year our team designed a robot with two subsystems, a hatch delivery system and a ball delivery system. The hatch delivery subsystem was able to grab hatch panels from a drop-off area at the side of the field, and then place and release those hatch panels on the side of the cargo bays. Our ball delivery subsystem was able to pick up balls from the ground and shoot them into the cargo bays. In this video, I'm going to show you how we implemented these subsystems in Java. And the reason I'm choosing to write the subsystem code first is because everything else in the robot depends on having the subsystems written. Like you can see in this diagram, subsystems are at the bottom of the Java classes and are where your program will actually interact with the motors and the pneumatics. So now let's talk about how we would program one of these subsystems in the code. As I've mentioned before, each subsystem is represented as a Java class. So if you're watching this video, hopefully you have an understanding of how object-oriented programming works, so I'm not going to go into too much detail there, but let's see how we represent a subsystem as an object. So just like any object, our subsystems will have variables and methods. So for our variables, we're going to store things like our actuators. So if you remember from the previous video, our motors, compressors, solenoids, things like that, all of those are actually handled as an object in the code, and those objects will be variables in our subsystem class. We can also store our sensors this way, so our limit switch or our ultrasonic sensor, and then finally any other variables we need for our system state. So maybe that's our subsystem's position or the speed of its motors or anything like that. Now our subsystem will also have methods. So first we'll have methods to control our actuators, but it's important to keep these simple. So I wouldn't make a method that would lower our ball delivery subsystem, pick up a ball, lift it back up again, and then shoot it. That's too complicated for our subsystem method, and that would be better off in something called a command, which we'll talk about later. So for now, in our subsystem class, we're only going to stick to very simple methods. So I would have one method to raise our ball delivery subsystem, one method to shoot the ball, and maybe one method to pick up a ball. And then our method could also return information from any sensors that are on this subsystem. And that's how we'd structure our subsystem object in Java. Alright, so now we're ready to try making our own subsystem in the code. So first we're going to need to make a project. So if we do Control-Shift-P, that'll bring up this window. You might already see this create a new project option here at the top, but if not, you can always type it in the search bar, start typing, and then it should show up over here. So when we click that, we're going to make sure we pick template, then pick our language, so either C++ or Java, and then choose your project base. So I recommend picking Command Robot to follow along with these videos. All of them should work fine, but if you want to follow along, I'd strongly recommend using the Command Robot just to make sure everything works the exact same way. Then you can pick your folder, so where you want this project to be stored, give it a name, enter your team number, and then when you're all set, you can press Generate Project. I've already made my project, but you should follow these steps to create your own and follow along with this video. Awesome, so once you make your project, it should look like this on the left-hand side, and we'll already have the commands folder and the subsystems folder there for you, hopefully. If not, you can always make those for yourself. And then we'll also have this main.java file and robot.java file here too, which we'll talk a little bit about later. All the other files you can delete. And then I also have added in this RobotMap.java class, which I'll talk about in this video. The last thing I did here was this util folder, and so that's something I just added in, and I put in our double solenoid toggler and floatable solenoid classes, and so these are just files that our team has made in the past that make it a lot easier to work with pneumatics on your robot. So once you have this util folder, we're all ready to get started. So let's open up our subsystem folder. You should already have a subsystem in there. If you want, you can just rename that to BallDelivery.java, and that's going to be the first subsystem we're making today. If not, you can always create your own Java file by right-clicking and then New File, and then entering the name of your file that way. So I'm going to open up my BallDelivery.java, and I've already got this set up. So you can see here, I have my public class BallDelivery, and I'm extending SubsystemBase. And so that's this file here that I'm importing at the top. So if this import isn't working, you'll need to go to the WPI lib documentation and follow the steps on how to get the new command framework into your project. But if you've already followed the steps that I showed you and created a new command robot project, this shouldn't be a problem. So just delete all of the code inside this class so we start out with a nice empty blank slate like this, and we're ready to get started making our first subsystem. So if you remember from earlier, our BallDelivery subsystem has two parts. It has motors that can shoot out a ball or intake a ball, and then it also has pistons that can raise and lower the whole subsystem up and down. So that means we're going to need to make variables that hold these actuators for us. So first, I'm going to make a vector, and I'm going to call it left motor equals new vector like this. And I'm going to copy paste this, do the same thing for the right motor. And I'm also going to make these private like that, because these actuator variables are going to be only for our BallDelivery class. We don't want any other subsystems or commands to be working directly with these. Instead, we're going to make methods that make it easier for those things to work with our subsystem. The next thing we're missing here is the argument, which is the port number where our motor controllers are plugged into. So what our team does, just to make things a little bit cleaner and more organized, is we have a separate file called RobotMap, which you can see over here, and it has a whole bunch of constants in it like this. And so how you do a constant in Java is this final word here, which just means this value is never going to change for the entire program. So here we're saying left motor is equal to 3 and right motor is equal to 4. And so that's just the ports where our motor controllers are plugged into on the RoboRio. And we can access these numbers from inside our BallDelivery class by just typing in RobotMap.leftMotor, just like that. And you can see it's underlined there. In order to import that, we can just do control period and import RobotMap, and we'll do the same thing for this vector class. So control period, import, and that should get rid of some of the underlines. For our right motor, we're just going to copy and paste this in there as well and rename it to the right motor port. Awesome, so now we have our motors and we just need to add the pistons that will lift our subsystem up and down. So for this, I'm going to make a private double solenoid toggler. And so that's our class over here that our team has made in the past to just make it a little bit easier. I'm going to call it pistons, and I'm going to make it equal to RobotMap.pistons. And so if we control click on this, it'll take us over to the robot map right where we've declared this pistons here. And I'm just making it equal to a new double solenoid toggler using ports 6 and 7. And so these are actually the ports on the pneumatic control module, or PCM. And so the reason we're having this robot map file with all of our constants in one place, it just makes it a lot easier if we ever need to change some ports or move our wiring around, then we have it all in one place in the code where we can easily access it. So we have this pistons object that we've made over here, and we can put it into our BallDelivery subsystem with this line, pistons equals RobotMap.pistons, like that. So now we've got our variables done, it's time to actually start making the methods. So first we're going to make a method called power, and what this will do is set the speed of our left and right motors. And so the reason I'm making one method that sets both motors at the same time is because for this subsystem, the motors should always be moving together. When we're shooting, the motors both move at the same time, and when we're intaking a ball, they should also both move at the same time. So it'll be easier for our other commands to access this method and control the motors if we just make one simple method that does it. So I'm going to make a method called public void power. It's going to take in a double called speed, and then inside this method I'll just say left motor dot set speed, and then right motor dot set negative speed. And the reason I'm putting this negative sign here is because our right motor needs to be rotating in the opposite direction. So if you can imagine our two motors spinning, one is on either side of the ball, when we're shooting out the ball, they actually need to be moving in opposite directions in order to shoot the ball. And so that's what this negative sign is doing here. It actually just flips the direction of the motor. So if you remember when I mentioned that motor speeds go from -1 to 1, and 1 is forwards, -1 is backwards, we can actually just flip the sign and make it negative, and that will flip the direction of the motor. Awesome, so now we have this method called power that will set the speed of our motors, and we can put any number in between -1 and 1 in order to make our motors start moving. And so now you might be asking, well, what happens if someone puts a number like 2 into this method? What would happen to the motors? So in order to make sure this doesn't happen, let's actually make an if statement and just say if speed is bigger than 1, speed is equal to 1. So now anytime this power method is called, we'll never have that problem because this if statement will automatically lower it down to 1 if someone puts in a number that is too big. And in the same way, we'll need one that goes the opposite direction. So if speed is smaller than -1, speed is equal to -1. So this will just prevent the user from putting in a number that is maybe too small. All right, awesome. This is looking really good so far. The last thing that we need to think about is a little bit more complicated, and it comes from how the controller works. So the controller is actually a little bit similar to the motor speed in that if you move the joystick up, it'll give you a value of 1, and if you move it down, it gives you a value of -1. The tricky thing is that when the joystick is exactly in the middle, it doesn't always give a value of exactly 0. Sometimes it'll say maybe 0.001 or -0.02. It'll be close to 0, but might not give the exact value. So what we're going to do to stop that is I'm going to make another if statement and say if math.abs speed is bigger than 0.1. And so what this abs is doing is just basically ignoring the sign. So we don't care if it's negative or not, just if the part after the sign is bigger than 0.1, then we're going to set the speed of the motors. So this means if our joystick is in the middle and it gives numbers that aren't exactly 0, our code will ignore them and it won't just start shooting randomly when we don't want it to. And so in the case that our joystick is in the middle and we don't want to be moving the motors, we'll call a stop method here. And I know we haven't made that method yet, so I'll go do that quickly. Public void stop. And in our stop method, all we want to do is set the speeds to 0. So that's going to be pretty simple. Left motor dot set 0, and then right motor dot set to 0 as well. And that's going to stop both of the motors for us. And so now we have our power method that can set the speed to any value we want, and we have a stop method that will quickly stop both of our motors. Awesome, so our motors are looking really good now. The last thing I want to do is make a getSpeed method that will actually return how fast our shooter is currently shooting. So it should look like this. Public double getSpeed. And now what should we return here? We don't actually have any variables that are keeping track of the speed, but luckily our motor objects actually remember the speed that we put into them through this set method. So I can say return left motor.get, and that will give me the current speed of the motor and then return it. And so that means that our method will work exactly as we want it to. Now, the reason I'm using the left motor instead of the right is because if you remember up here, we said right motor.set negative speed. And so that means our right motor is always going to be flipped from the number we put in. So it's important that we have our left motor here in this method so that we actually return the correct speed. Awesome, so now we're halfway done. We've already got all of the methods for our motors. Now let's move on to our pistons. So our pistons should be able to raise and lower the subsystem, but I also want to add a toggle method that will quickly flip between the two positions. So let's see what that would look like. First, I'll start with a raise method. And so this raise method should just lift up the pistons. Now, because of the way we built our subsystem, in order to lift up the shooter, we actually need to retract the pistons and pull them in. So I'm going to say pistons.retract like that. And that's all we need to do for our raise method is just retract those pistons. So it's going to be pretty similar for our lower method. So I'll just call this one public void lower. And I'll just say pistons.extend like that. And so that's just going to do the exact opposite. To lower our subsystem, we're going to extend our pistons down to the ground. And then our last one is going to be a toggle method. And this is going to be pretty straightforward too. We'll say public void toggle pistons. And I'm going to say pistons dot toggle right there. And so the reason that we can use this toggle method is because we have our double solenoid toggler class that can handle all that stuff for us. So now we have our 3 pistons methods, and I think I might want to add one more method that will just return true if our subsystem is raised. So I'm going to make this one called public boolean is raised like this. And this is going to tell us if our subsystem is currently up or down. So what this is going to look like is I'm going to return not pistons.extended. And the reason I have this exclamation mark here is because when our subsystem is raised, the pistons are actually retracted, like you can see in this method. So I actually need this exclamation mark in order to flip this and get the right answer. So if our pistons are extended, our subsystem is not raised. All right, awesome. This is looking really good. We have our motor methods and our piston methods. So the last thing we need to add to our code has to do with the very start of the match, when our robot has to be in a certain frame perimeter. And so that means our shooter has to be lifted up in order to make our robot small enough. So we basically want to add to our code a line that will raise our shooter as soon as the match starts. And the best way to do that is in the constructor. So we actually don't have one yet, so I'll make that now. And it's going to be called public BallDelivery. And in here, all we need to do is just put raise method like that. And so that means as soon as our subsystem is created, we're going to call this raise method, and it's going to retract our pistons and lift up our shooter. So there you go. That's all we need to do in order to make our first subsystem in Java. If you've been following along with me, great job. In the next video, we're going to continue by making our final two subsystems, which will be the hatch delivery and the drivetrain. Thanks for watching, and I'll see you in the next video.